We have been covering multiple topics so far, right? And today we'll do a recap of what's gonna happen, basically what can come up on the first quiz, the midterm quiz. So here's a quick recap of the topics that we covered so far. We talk about Linux basic, the file structure, Linux, the shell command, how do you assign control over different users, the shell scripting. The assignment one is basically all about shell scripting. Regular expression, Git, all right? So how to use Git, um, how can you say commit and push your change to the share repository so that you can uh, in a team, right, edit the code together. The basic of C, data types, pointers, pointers of pointers, pointer of pointers, basically how does pointer works. And how can we use like multiple dimensional data using pointers. Memory allocations, data structure in C, right, which in throughout the lectures, we cover how to implement linked lists. The stack, queue, and the binary search tree, right? So if there's anything that required for data structure, it would be something that we already covered in this class, right? I did make a mistake in previous, not the last semester, but the way like the first time I basically teach this class, I was basically asking you to do something that was not covered in another class, but I thought it's already covered. So I will make sure this is not the case. Um, that semester I need to curve like crazy, and I do curve, so don't worry about that. I do give partial credit as well if you have a question that's kind of like, hey, it's almost the answer, but it's not the answer yet, so I give partial credit on the exam for that. I do understand the time constraint of the exam versus assignment. So now let's go through the previous exam. How many people have a chance to look through them yet? Actually, first of all, any question about these topics that you want me to review in particular? Binary search tree, right? So basically, let me do a blank slides here and talk about, okay, a couple of things, a double pointer and binary search tree. So let's do binary search tree first because that's the first thing that show up on the chat, right? So what is a binary tree? Can someone tell me what is a binary tree? And what's the difference between a binary tree and a linked list? So I'll start from a linked list, right? What's the difference between a binary tree and a linked list? Yes. So the binary tree is a tree where if you have a parent, you can have up to two child, right? The left, there's going to be a left child and the right child. So the way you implement the binary tree is you will create the node, right? That would basically represent the parent. So the node would consist of the data itself, right? Whatever data format you want, and the pointer that point to this node. Right? So this is basically how the linked list is being built. The difference is you now need two pointer because you want to point to the left and point to the right. So in this case, if you look at inside the implementation of the node, right? So you have data as usual, but you're going to have the pointer that is pointing to the left and pointing to the right. Then the way it can be visualized is you have this node, right? And these are the pointer to the left and the pointer to the right. And the data goes in here. The pointer basically point to the address of another node that are to the left and the one that's to the right. And this go on and on and on until that's the end of your tree. Right? So this is a binary tree in a high level. what you need to do is think, I guess, put yourself in the shoe of the, like, let's look in at the linked list, right? And you want to insert something to the linked list. You make sure the pointer now point to the new items that you want to add. Over here, you then, the difference is you need to go to the right subtree. So if you have to go to the left, make sure you go to the left. If you have to go to the right, you then go to the right. This depends on the implementation. Some tree will ask you to do certain things. So this kind of vary based on the assumption about the tree types, right? And when you add the leaf, that's when you can insert things. So let's say, what is a binary search tree? What is a property of the binary search tree that makes it unique? So if I have a node I in here, what can I tell about everything that goes into the left side and everything that goes into the right side? So this is a parent. This is the left subtree. And the right subtree. So what's the difference? What makes this unique? What goes to the left? If I need to add a new items, how can I tell, do I go to the left or do I go to the right? Everything on the left has to be smaller. So everything here has to be smaller than I. Everything here has to be bigger than I or equal to. I mean, the equal can go either to the left and to the right as long as it's consistent, right? And that's basically binary search tree. That's basically binary search tree. Um, on the exam, because this is not a data structure class, I can tell you one thing. I'm not gonna ask you to implement this whole thing. By the way, that was the assignment 2, right? And that's also the extra credit of the assignment 2. So I already know that this is a little bit harder. If I'm asking something related to this, it will be something pretty specific, maybe just one of 2 lines of code that you have to write. And I will already have something that is like the starter code that you can basically take a look and see what's going on, right? So any question about binary search tree before we go through the concept of the pointer? And to be specific, the double pointer. So about double pointer, right? One thing that we have been talking so far is a pointer can be used as an array, right? We said this and it's kind of hopefully understandable. Basically, when you malloc, you basically have an array of something you can put in, right? Everyone with me so far about the pointer? The way I would envision double pointer is I would write it this way. So if I look at double pointer this way, this is your array, right? So if I have a star again, what is that? Is an array of what? So I can put any type in the array, right? But when I do star star, it's an array of pointer. Everything that goes in here are pointer. So because everything that can go into each of these array are pointers, it means that I can then use the array to represent another array. Each item would point to another array. Here, as you can see here, this will point to another array here. This point to another array here. This point to another array here, right? So on and so forth. And this is the kind of like the conceptual concept behind this. So let me, yes. if you want to get an input, you should from the user, we should scanf, right? Um, yes. There are multiple ways to take the input. Scanf is one of the really common ones. You can do get C, which would get a character. Get S would get a string. So those works as well, right? But most of the time, scanf is one of the really, really common one. So can someone ask me a little bit more specific questions about the double pointer so that we can talk a little bit more and have a discussion? Can you have a pointer that's dynamic, like you can change according to input size? Yes. Yeah. So let's say I have the pointer called PTR that initially you do Monologue, right? You Monologue and it is about this many items then. It right now can hold 6 items, right? And I say, hey, I insert things into this pointer, 1, 2, 4, 8, 7, 6, and say, hey, I want to add more things. So if the question is basically now, what do we do, right? If you want to add more things into this array, right? Is that the question? So in that case, right, what do you need to do is first you create another pointer. Let's say it's called temp. Temp. Apparently, I cannot spell. Sorry about that, guys. It's temp, right? And then I say I'm gonna malloc. So one of the common techniques to increase the size is you will multiply by 2, or you double the size. So in this case, let's say you malloc 6, right? Malloc 6 item. Over here will be 6 multiplied by 2 multiplied by size of whatever this item, let's say it's integer, right? In that case, you will now have 12 blocks, right? So you first malloc a free slot for temp that has a bunch of things that you can put in, a bigger array, basically. Then you do the copy. So over here is the code to copy everything from PTR to temp, right? So you need to manually write that code. It can be, it's just basically going through each element and doing the copy. So 1, 2, 4, 8, 7, 6 will be copies to here. Then you free up pointer so that this particular array is now gone. We deallocate that. Then you say pointer is now equal temp. Basically now pointer would point here. We then get a bigger array. So does that answer your questions? And let's say you have an input that basically waiting for the user to tell, okay, what's the input size, right? So let's say you scanf. Yes, exactly. You can reallocate for this. Reallocate would work too. So let me show you the definition of reallocate. Right, see reference here. Can you see the screen? Yeah. So you can also use reallocate for this because we haven't covered this function, but since you asked, yes, you can use reallocate. You put in the pointer and the new size, it would reallocate and do the copy for you. Great question. There's another question when we said a pointer without assigning to anything yet. That actually depends on the implementation of what's happening. And this kind of determined by the version of the compiler that you're working on. For safety purposes, make sure that points to null. Make sure that's point to null. So great question. in many cases it would be default to like 0 or null, but sometimes it doesn't do that for you. So the safest thing you can do is point to null. And yes, you look at the bug and it's because of this. So for GCC, it doesn't do that for you. So the safest thing you can do is point to null. So there's another question of a pointer to the function, right? So let's say you have a function somewhere here. So what do I need when I declare a function? So let's say I want to define a function. What do I have to type in? What do I need for the function signature? For the function signature, when I want to declare a function, what do I need to tell the computer about the function? The return type, yes. What else? The input type, right? So it should have the return type. And I guess the function name, right? For sure. And in parentheses, there's the inputs, right? So we are with me so far. You need return type and input types, right? So the concept of the function pointer is basically instead of pointing to a data, now you point to the function. You point to the function like this, right? But similar to the data, what do I need to declare when I want to create a pointer that points to the data? I would do something like this, right? Int star ptr. So what does this tell the computer? What's the type of this pointer? It's an int pointer, right? It's a pointer that points to the integer data type. Now, let's say I want to point to the function. I can, well, function has a type as well. Fun fact. So if you finish this class and you go to the parallel and functional programming, I basically would cover function does have a type. The type of the function is based on two things, the input type and the output type, right? Similar to how you write a math function. If I write a function in math, let's say f of 0 and 1, right? What does it tell you? It's a function that takes two inputs. Those inputs are number, right? It probably do some calculation. It returns some output. So to make sure the pointer can correctly point to the function, what do you need to give the hints to the program? You need the type of the input. You need how many inputs, and you need what's the return type, right? So to declare a function pointer, this is what you can do. Well, obviously you need a pointer name, right? You definitely need the pointer name and declare that, hey, there's a function. Put parentheses in to make things clean and neat. This is going to be the input type, and this is going to be the return type. So let's say I want to point to the function that takes two inputs as one character followed by one integer. What do I write at the parentheses at the back? Character, right? And integer. And let's say it's return, I don't know, as an integer. I will just say int over here. This means that I create a pointer that can point to the function that takes in a character that also take in integer and return the type int, right? Then if I want to actually point to this function, let's say a function is called func, I can write this, ptr equal, right, func. It's gonna equal to address of function, right? Any questions about the function? Is it more clear now that because you need to tell the language has the strict requirement that if you want to use a function pointer, you're supposed to tell what are the inputs and what are the output so that when I use it, so that when I use it, I can actually run it, right? And the way you can run this, because now PTR points to function, right? So I can do PTR, right? And I dereference this, and then I put in inputs like number, because it's texture and int. I can do K followed by, I don't know, 10. This would run the function with the input letter K and the number 10. All right. Any questions about function pointer? Is it more clear, or is it still confusing? I mean, it's totally okay to let me know. You can DM me too. Like send me the private message. I still don't know. Otherwise, I assume you know more now. So the way to try this out, right? The way to try this out is the easiest way to try to learn how to use function pointers. This one thing you would do is, well, one thing you can try to do is to declare your own function. I don't know, like int add int a int b, right? And you implement this. Basically, this return, right? A plus b. And you have another function. Let's say like we call it multiply. Int a and int b. This return a multiplied by b. Try to use a function pointer so that it points to these two functions at your demand, basically in the main function. This is going to be a quick exercise, doesn't take much, but you will learn how to declare the function pointer and to use the function pointer. So basically use function pointer to point at, add, and multiply at your command. All right. Yes, I agree with that. This will be a great addition to the in-class exercise. Because we only did quicksort, right? Let me pull up the quicksort lecture. Yeah, we only have quicksort, to be honest. That's also, I just spot another question. It only appear on my laptop. Doesn't appear on my desktop. I don't know why. So there's a question, why do I do this? And not like star PTR equal func. Actually, this is wrong. I forgot I need to add the address of the function. So you want to assign the pointer, not the value of the pointer. So hopefully that's not confusing. So you want to assign the pointer itself, not the value of the pointer. So you would assign the address of the function to the pointer. Does another question about in assignment, will our point be deducted if we don't follow what's suggested? No, but okay, let me put it this way. If you don't follow the recommendation and the code doesn't do something weird and buggy, then you're okay. It doesn't answer your question. It doesn't do something weird or like you ended up like brute force. Like instead of writing a loop, for example, let me give you this example. If you have to loop around 100 times, you type in 100 loop iteration manually without using for loop, then your point will be deducted because it's wrong. Sorry. It's kind of like, don't do it that way, please, kind of thing. So it's the style point will be deducted. But if you don't do something really odd with the code, you'll be fine. Does that answer your question? I'm sorry, it's kind of hand wavy answer, I know, but uh, if you look at your code and you don't feel like, okay, that's a really bad way to implement my code, then you'll be fine. Like, and I stress on the word really, right? Really. So it has to be really odd, really like weird kind of code looking. Yeah. Um, all right. Anything else before we go to the sample exam? Because otherwise I'm gonna switch over to another screen that I have the exam opening up. So let me stop sharing this. And that's the share button. Sorry, look at the wrong monitor. Here. Can you see the exam? All right, awesome. So let me go through this one by one, right? If you have a chance to look at this, you might have realized problem 3, that's some of this is on your assignment too. So we are not going to go to problem 3. We're not going to go through problem 3. I will put the pseudocode for problem 2, but feel free to try it out. Problem 1 is this. The first question, let me zoom it in. The first question say, hey, your friend comes in and asks you, I type in ls, but it got command not found. Anyone want to take a guess what happened? I type ls, but I got command not found. Guess what happened? Or I guess you might accidentally remove it from Linux. It's not in bin. Yes, that's one thing that can happen. uh PowerShell. So I guess those are possibilities. So those are correct answer that can happen. But these are the more open-end question that you can basically use imagination on what could have happened. What one of the most common things is maybe someone modified the path directory. If someone modified the path directory, what happened? When you type in ls, it will not have /bin, which means it will not be able to find /bin/ls, right? So that's one thing that can happen. Someone can move ls out of /bin. I don't know. Someone has the root privilege, become the super user, and I do mv/bin/ls and put that into my home directory. Well, then anyone on the computer now cannot use ls because the command is gone. Any questions about the first one? This is pretty simple. The second question asks you to write a script or a line, basically a command or the script to print. So when you type in git log, it gives you a tons of log for every commit, basically every changes to the code by everyone, right? So I want to make sure I just parse this and print in bracket the name of the person who edit, right? Who edit and the date in this format. It turns out that you can easily do this. So for the answer, you can easily do this through an option, right, in git log. So the option is called git log, right? Then you add the option double dash pretty. Pretty will basically print the result in whatever format you want to configure. Whatever format you want to configure. So in this case, let me move a chat box here so I can see your question if you have one. Right, so you can do this. Pretty is going to equal to your own format. Your own format start with this bracket. I want to print the author name in bracket and colon. We will bracket here, and colon, followed by %cd, that's the date, right? and you type in, specify the date format. Equal format. And then you put in %D for day, %B for month, and %Y for year. Right? And this way you can basically have the pretty format output, right, for this particular question. The next question is pretty simple, but it can be long. The answer for this, it can be long because it asks you to do a few things. So what we ask is, in question 3, the assignment to the sorted list question, I want to ask you to write a script that generates the input and also check the input that it follow the correct format, right? That follow the correct format. So the way you do this is basically for the input generation, you then, right, you then loop over the number given by the second argument becomes the number. Then you basically do the echo, right? Echo the input in any random. Basically, you randomly generate input. It can be I10, I20, D15, D10, right? Whatever, n number of lines. Then you have the checker that checked the input. So you read the file given and make sure that all lines follow the formatting. So this is basically a bunch of loop and if else. So this can be a long answer. This is basically would give you familiarity over writing loop and if else using shell script. The next question is quicksort. We didn't cover in class about how quicksort works, but the idea is this. All right, so let's say I have a quicksort function. And in this case, I have the input array and the size, right? Let's say this is your array, 1, 10, 2, 4, 9, 7, right? How quicksort works is it would pick one random element here. Can someone give me a random number in this array so that we can start the first split? 9. So can we pick something in the middle? Actually, let's pick something in the middle. Let's 4 or 7. Can someone tell me either 4 or 7? Give me one number. Let's do 7. Right? Let's do 7. The way quicksort works is it compare everything in this array, split it up into 2 sub-array. So you would malloc the array called left, the one also called right. Right? You compare them so that you know, okay, 1 is less than 7. So anything less than that number you pick, this one is called pivot. Anything less than that, go to the left. 1, 2, and 4 go to the left. Anything bigger than that would go to the right. So 9 and 10 goes here. Then you do recursion, repeat the same step. Now you split the left, split the right. So you get, so let's say you pick 2 over here. So the left becomes just 1 element. Right? Over here, let's say you pick 9. The left is empty set. And over here, the right is 10. So now when the function call comes back, you merge. You merge the left side. Basically, now you have the left array. And you stick the pivot in the middle. And you put in the right. Right? So the way this is done is left array is 1. Pivot is 2. right is 4. So now the outcome array is 1, 2, 4. Over here, right over here, the left array is empty. Pivot is 9, right is 10. So you're gonna get the array 9 and 10. You go back one level, merge again. Left is 1, 2, and 4. Pivot is 7. Then the right side is 9 and 10. So after you're done, you get the sorted array. So the way you implement this, right? The way you would implement this is, let me find a room. So inside a function called quicksort, you would first, I guess, pick a pivot. Then you malloc the left side. You malloc the right side. Then you put anything that less than pivot to the left side. Otherwise, you go to the right side. Then you call quicksort left, and then the number of left. Quicksort right, and the number of right side items. And when this is done, when you call back, when you get the function callback, the left will be sorted, the right will be sorted, because assuming the quicksort works correctly, this recursion would give you correct results. So after the recursion, right? After the recursion, the left side is sorted, the right side is sorted. So then you combine, right? Basically now your input array, you basically rewrite with left, combine with pivot, combine with right. Right now you have all the data sorted, and then you free left and free right. So this is how you can write quicksort on C, right? Use recursion. There should be the check at the beginning. If the size is 1, return the array directly. You don't have to do anything, right? And that's all. Basically, that's all. We will skip the third question, sorted list, because that's your assignment 2. We can ask, you can ask about this later. That's fine. And now let's talk about the last question. So I'll give you some time to read the last question a little bit. So now that you look at this code, right? One thing is character is 1 byte, integer is 2 bytes, long is 4 bytes, right? And the snippet code below asks you to follow this first and fill in the answer, right? So you notice A, B, and C are pointers. How many elements did I just allocate for A? Unsigned char is 1 byte, right? Unsigned char is 1 byte. So 1000 multiplied by 1, how many bytes is that? How many bytes is that? What is 10,000 multiplied by 1? 10,000. So that's the answer here. And then I make sure B points to A and C points to A. Right? I make sure B and C points to A. This code here basically from A from 0 to a of 24.99, you will have the value 0 to 24.99. But I start from I equal 1000 to 10,000. I'm gonna overwrite anything from here, b plus I, b plus I. So from b of 2000 down to b of 10,000, I guess 99999. It is the value is gonna equal to 2000 mod 256 down to 9999 mod 256. So so the unsigned part, I just want to make sure there's no like negative number here. Just make things simpler. So everything is a positive number. The bit is treated as a binary and decimal, like the same thing. So now if you look at this code, B2000, B is 1 byte, right? A are 2 bytes. So basically over here from A of 1000 down to A of how much? 4,999. Basically the last elements of A, the data has been changed. The data has been changed. So your resulting array has two parts. The part that is going to be 0, 1, 2, blah, blah, blah. This is A of 0 down to A of 999. And from here onward, from B of 2000 to B of 9999 will be whatever goes in the second loop, right? The first set of questions is easy. So I'll do this and I'll leave maybe 10 or 15 minutes of your time to work on the other few questions, and we'll come back and answer this together. All right. So the first question is, what is the value of A plus 16? A is the integer pointer, right? Int star. So when you plus 16, you go 32 bytes over. If I say A is starting at 0x1000, right? This is basically 0x1000 plus 32 in decimal. 32 in decimal is 20 in hexadecimal. So this is basically 1020 hexadecimal. What's this number? This is basically A16, so this is going to equal to 16. Next, what is the value of B plus 16? B is an unsigned char star. So B plus 16 is 10,000, right? 0x 10,000 plus 16 in decimal. 16 in decimal is 0x10. So this is 0x 10, 10. The value of B of 16 is going to equal to A of 8. So this is number 8. All right. So now I'm going to leave you to work on the remaining questions down to, so you will notice these two questions are the same as these two. So it's the same thing. But I'll leave you 10 minutes and work on this first before I proceed onward. Is that okay? So let's leave like maybe 10 minutes of time. So let's do a 10 minutes, like just look at this question and we'll come back in 10 minutes around 3:05 so that you can kind of catch up and read the code. This file is on Canvas. You can take a look at that. Start from question 6 here. Try to go as far as you can so that when I go through the answer, you might have questions. Wait, why isn't it this way? Because this is the part that gets tricky. All right, so we'll see each other in 10 minutes. We'll come back and we will resume. Okay, so let me pause the recorder.